Okay, boys and girls, we continue our lesson. Okay, take out your lesson number 30 about Doppler effect. Okay, before that, we recall a bit what is Doppler effect. Doppler effect is the frequency that we observe, it will be changed. Why it changed? When the source is moving towards or away from us. We are the observer. Okay, we are the observer. We observe the frequency. Frequency observed, it will be changed. Okay, when it will be changed is because in moving, the source is moving away or towards to us. So this effect is called Doppler effect. Okay, so at here, how am I going to memorize? For myself, my way is I using the slinky spring to remember it. Okay, if let's say away from me, so I will pull the slinky spring further away. So at the end, from here to here, I assume this is called wavelength. If away from me, wavelength will increase. If towards to me, so it's nearer, so the slinky spring will be nearer. So the wavelength will become shorter at here. Okay, so this part, if nearer towards to us, the wavelength becomes shorter. Okay, the frequency is opposite to the wavelength. Okay, if your wavelength is longer, then the one frequency that you observe will become decreases, lower observed frequency. The frequency that we observe will be decreases. So the formula that we apply at here, these two formula actually are the same. Just one using plus, one using minus. Since we are reducing the observed frequency, so we must in mathematics the value divided by a big value so that your observed frequency will be decreases. So at here, this value we should using plus, okay? The speed plus the speed of the source, okay? So plus. So at the end, the bottom part, the value divided by a big value at here, so your observed frequency will decrease. Okay? So in another way, if nearer to us, the observed frequency will increase. So at here, the bottom part at here actually should be a small value. So we put a negative. Of course, how we get these two formula, actually there is a series of formula substitution here and there. At the end, we get this formula lah, okay? So in overallly, we just say that this is the formula. Plus minus, actually, it depends on you towards or away. Okay, so we are going to using this formula to solve our past year question. Last week we stopped at question number 1, so now we continue with question number 2. Okay, here. In one of the first experiment to demonstrate the Doppler effect, the train is the source, okay, playing a note of frequency. So this one is actually the frequency of the source. Okay, so this one frequency of the source is 440 because train is the source. The difference in observed frequency of the notes as the train directly towards to the, here keyword, directly approach. Approach, that means that towards. Approach, that means towards. So when towards, ask yourself, your frequency, observed frequency will be increase or decrease. So ask yourself, observed frequency, if towards, wavelength becomes shorter. So your observed frequency will be increases. So here increases, okay? They say that difference is 22. That means that your observed frequency right now is 440 plus 22. We increase by 22. Okay, the difference in observed frequency is 22. So your observed frequency increased by 22 hertz. Speed of the sound, this is your V. At what speed was the train moving? Again, the train is your source. Train is your source. Okay, so at here, what the question they're asking? What is the speed of the train? Vs. Okay, so at here, the formula that we apply, FO equals to V over V, Vs, then Fs. So ask yourself, you should using minus or positive. Okay, negative or positive, what? Add or minus. Okay, you should using add or minus. So at here, we understand that it's approach to us, right? Okay, so if here, this one, towards to us. Can you see that? Towards to us, we're using minus. Because at the end, our FO will be increases. So we are using a minus at here. This one, we're using minus. Okay, can you try? And then tell me your answer. Basically, I already tell you all the information already. Okay, we read the question, we find it out. What is this frequency? Is observed frequency or this is the source frequency? Frequency due to the source. Because now they say the train playing a note of frequency. So this is the frequency due to the train. So this is the frequency from the source. Then the observed frequency difference is 22. We understand approach, meaning that towards. If towards, your observed frequency should be increased. So we should using the original for 440 plus 22. It increases. Wawa already get the answer. Let me have a look. Wawa correct. Wawa, you may try question number 3 while I'm waiting for others. Washini correct. How about others? If I didn't give you hints, do you able to identify what is this frequency, what is this speed, what is this train speed? Do you able to identify? Wesley correct, Prasan correct. You have to determine by yourself using plus or minus. Read the question and identify it out. So this one is 340 minus 340 minus Vs. The source is 440. Your observed frequency is 440 plus 22. So at the end, you're using your mathematics, you should be able to get 16.2 ms negative 1. Answer should be B. You think correct? Fatima correct. So this question is considered quite straightforward. Only one part. Approach. So you have to think. Your observed frequency should be plus 22 or minus 22. And you have to think V minus Vs or V plus Vs. Okay, the next question, can you guys try? If I didn't give you hints, can you able to try? If you really cannot, then I will give you some hints I writing on my iPad here, so you can have a look. But those who can try by yourself, you try first. Approach. This one have to solve simultaneous for two cases. When towards, when away. Then based on these two cases, you do some simultaneous equation. You have to solve two cases, towards and away. Then you're using mathematics to do some simultaneous to find out what is your Vs. I can give hints until right now. The rest you try using your mathematic way. Jore correct. Jore already solved the problems. How about others? Speed of car. Car is the source to producing the sound. So actually they're asking you what is your Vs. Vashini, correct. How about others? Prasan, correct. Prasan, correct. Wesley, correct. I almost complete already. Okay, so case one, towards, away, you put whatever you know inside, then you're trying to solve these two. Because from time to time, towards or away, the car traveling at constant, that means that both case the speed doesn't change. So their VS should be the same. Their VS should be the same. We are going to find this VS. How are we going to find? So at here you will find that 340 fs. Another one also 340 fs. So we can using these two make a equation, simultaneous equation. Okay, so from here I solve until mathematics. Actually I can get Vs equals to 34 meter per second. Answer should be C. Is it okay? If okay, we are going to the page number 5. Pawan okay. How about others? Only Pawan? Wesley okay. Washini okay. Boyang Boyang is it okay? Fatima? Fatima okay? Okay, then we go to page number 5, dear. Number 4, question number 4. Okay, emergency vehicle sounds, okay, is as it accelerate along to between 2 points from X to Y. Okay, the frequency of the sound by the siren is 750. This one is the source emitted out. Okay, so this one is frequency due to the source. A person stand at X. Oh, okay. Person stand at X at here, and another one standing at Y. Describe the sound heard by the person at X and Y. Okay, boys and girls, 1 minute think. Standing at X, standing at Y. What kinds of sound they can hear? The frequency that they hear by the person is called observed frequency. It should be higher or lower? Wesley, correct. Wesley, correct. How about others? Washini, correct. Fawal, correct. Good job. Okay, if two words, your slinky spring become nearer to each other, so your wavelength should be decreased, your observed frequency should be increased. Okay, so it should be higher, not lower. So your answer should be C or D. Then for the X position is away. Here is away. Here is towards. Okay, so away, you can imagine the slinky spring is something like pulling away. So your wavelength actually increase, your observed frequency should be decreased. So at here, it should be lower than 750. Okay, is that clear for this question? Is it okay, dear? Yes, okay, we go to question number 5. Question number 5 a bit challenging. I can give you some hints, then you think about that lah. A car travel at a constant speed along the straight line P to Q. Okay. A loudspeaker attached to the car emits the sound. So this is the frequency due to the source. Okay. A stationary observer is standing at the point O. What does the observer hear when the car moves from P to Q? Okay, now P to Q. First question. Ask yourself, towards or away? Second question, observed frequency should be higher or lower? Observed frequency should be higher or lower? Then after that, Okay, if let's say at point P, this is the sound that got directly getting from the received from the receiver observer. Okay, then if let's say I make a point at here, A point. So when the car moving until this position, this is the part that we can observe. You will find that this angle, if let's say this is angle 1, this is angle 2. And point B, let's say point B at here. The car already traveled until point B. This is the angle 3. You will find that when it nearer to it, okay, second question, the angle actually will increases. Am I right? If angle increases, according to our formula, V minus V positive or negative, you have to decide, because you have to decide is towards or away times the observed times the source frequency. So at here, you have to ask yourself, Vs, this one is Vs due to the source. Okay, the Vs at here, Vs is actually V cos delta. Okay, the speed towards to the observer at here is actually V cos delta. This is the speed V cos delta here. Okay, so you ask yourself, when the angle increases, because we are from P to Q. Okay, so when delta increases, cos delta actually is increase or decrease. Then ask yourself, Vs is actually increase or decrease. Then last, your Vs increase or decrease, so what happened to your observed frequency? Okay, this is the few steps that I can guide you. Okay, so the sound actually will straightly from here to observer. It won't go like this and then go to your side 90 degree and turn. Sound won't be like this. Sound, they will straightly from the source to your observer. So this is the part of the sound source. But we don't know about this. We only know about this V. So what is my Vs? V cos delta. So I get Vs. Okay, so the Vs that we get, you have to think. When the angle keep on increasing, because we are nearer from P, moving from P to Q. So your angle increase, what happened to your cos delta? Then what happened to your Vs? What happened to your FO? Number 5, any of you give me the answer? No, Wesley, no. Almost there. Prasan correct. Prasan correct. Prasan correct. What Wesley asking? Wesley here, if this is a triangle, okay, cos is cos is CAH. So adjacent, this is V over VS. Wait. Why is not VS? Wait. So that means that this is not the hypotenuse. This is not hypotenuse. Wesley, this is not hypotenuse. So V cos delta. This one should be the hypotenuse. Although here writing 90 degree. Let me think. Well, let me have a look others. Is it Fawa? No, almost there. Fatima? No. Wesley, correct. Washini, correct. Wesley, your question later after lesson, I think again about your question. Okay, dear here. First question, P to Q actually is towards. Okay, it's towards. So if towards, this is towards. So first question, towards. If towards, frequency should be increased. So your answer should be C or D. It should be more than F. But then from P point to Q point, actually it should be increase or decrease. The frequency, although is more than, but this value will be increase or decrease. It depends on here, second part. Okay, for the second part at here, we make few point. Okay, the sound will be traveling towards from the source until the observer. Okay, so this is the angle. So this is the angle. We found that when we nearer to the Q point, your angle will become bigger. Okay, so when your angle become bigger, your cos theta, so you're trying to press your calculator, you will find that the value for this, it will decreases. Okay, cos theta, angle bigger, actually the value for cos theta actually is decreases. So at the end, your Vs also decreases. Your observed frequency, this one becomes smaller. So your observed frequency actually is Vs. Wait, let me have a look. Vs. It should be positive. Oh, this one is towards. So towards at here, it should be a minus. Okay, this one should be a minus. So at here, let me change. It should be minus. So this value should be minus. So minus a small value, that means that your overall your observed frequency is small. Okay, minus this one, actually this is more, that means that the bottom part here, the value still high lah. Okay, the value still high. So at here, overall from P to Q, we found that the observed frequency overall will be greater than the source frequency, but overall from P to Q is still decreasing. Answer should be C. Okay, so boys and girls, can you go to your page number 6? A train travel at a constant high speed along this one settle. Is it okay? I didn't ask you. I just goes to the next page. Okay, okay, here. Travel at a constant high speed along a straight horizontal track towards, keyword towards. An observer standing. Okay, the train sound its horns continuous as it approach until t equals to z, from t equals to 0 until it's well past at t equals to 2. Until it is well past the observer at time t equals to t2, the train passed the observer at time t equals to t1. That means that at here, t equals to 0. At here, t equals to t1. Then t equals to t2. So here is two words. Then can you sketch the variations of the frequency by the observer with the time? Okay, from t equals to 0 until t equals to t1. Ask yourself, away or towards? Away or towards? First question, away or towards? Then frequency, away or towards? So your observed frequency, it should be higher or lower than your your source frequency. Ask yourself. So from t equals to t1 to t equals to t2, again ask yourself, away or towards? Second question, your observed frequency is greater or smaller than your source frequency? Okay. Any of you know how to sketch the frequency? Always read the question, ask yourself, away or towards, what happened to the frequency? Because Doppler effect is talking about the observed frequency. Any of you know? First one should be draw higher or lower than your Fs. Second part actually should be higher or smaller, lower than your Fs. Fatima, let me have a look. Yes, Fatima. So first is is away. No, it's towards. At start is towards. Then after that at here, the train is away. Here is away. Here is towards. Okay, at start is towards, later on is away. If towards, nearer, the slinky spring nearer, wavelength will be shorter, so your frequency should be higher. So at here, you can draw whatever at here, higher than your Fs. Then that is correct answer. Okay, then away. Away, that means that your slinky spring away. So wavelength longer, then your observed frequency should be smaller. So actually, you should be draw something like this. Okay, normally we will draw a line, like connect them together, something like this. That's all. Okay, here is approach towards, or I say towards. So your FO greater than Fs. This is away. So your FO smaller than your Fs. Is it okay? If okay, we are going to page number 7. Okay, Wesley, Fatima, okay. So at here, we go to your next page. Next page at here is let me have a look. Okay, a child sit on a rotating horizontal platform in the playground. The child moves with a constant speed along a circular path. Okay, the observer is standing a long distance away from the child. During one particular revolutions, the child is moving with the speed 7.5 meter per second. Oh, start blowing a whistle. So at here, the child is the source, you know. So now your source is rotating. Okay, the source is rotating. Okay, and stop blowing it at point Q on a circular path. Okay, so at here the sound, emit is the keyword. So this is the source. So this is the frequency due to the source. Speed of the sound in the air, this is V. Determine the frequency. Maximum frequency, that means that F maximum heard by the observer. So this is FO. Maximum. So at here, if maximum FO, meaning that is away or towards, ask yourself, frequency is higher, that means wavelength shorter, that means that towards. So this one is must be towards. So this is towards, here is away. It's rotating in this way. Okay, so that means that you should having a look for this by using the formula FO equals to VS, FS. Ask yourself, should be plus or minus for this part. If maximum frequency, that means that it should be towards. Okay, so that you can get a maximum. How do I know frequency is higher? Because here they say maximum frequency. Okay, maximum frequency. And then some more at here, this is towards. Observer is standing at here. It's towards. So at here, the maximum frequency can be observed by the observer due to this towards. So this must be a FO must be get a higher value than your FS. Ask yourself, here should be plus or minus. Person, okay? Yes, Wesley, very good. Where is your friend Tony? Okay, here, if towards towards FO higher, that means this one, we need to put a negative. Okay, we need to put a negative. Farewell correct, but I want to make it 2 or 3 significant figure. Okay, so at here, the observed frequency that we can accept, we can get, this one is 330 minus the speed due to the source. You see, the child moving with 7.5, blowing the sound. So this is the sound, speed of the sound, speed of the source. Okay, so this one 7.5 times the Fs 950. So your answer should be 970 hertz. 970 hertz. Correct, Vashini? Correct, Vashini. Okay, so at here, next question. Describe the variations in the frequency heard by the observer. Okay, here. In the frequency of the observer. Oh, okay. So how's the frequency change? How's the frequency change when it moving? Fawal can put 972 Hertz. Yes, can. Okay. Here, this question, we are starting from this point. So this is the maximum frequency. Am I right? After that, what's going on with your frequency? What's going on when it turn like this? What's going on with your frequency? Okay, so at here, we count for towards. We can also count for away, right? Away. So when away, what happened to your frequency? So can you count? If let's say away, just now is towards. Now if away, V over V, Vs, Fs. Away, we should use plus at here. Okay, count for me. If it is away, what happened to your frequency? Smaller frequency. So what is the value? Fatima correct. Vashini correct. Fawal correct. So first, 2 marks. How you get the 2 marks? How they change? Okay, the frequency changes by the observed by the observer lah. Okay, the frequency change. First point you will get mark is you mentioning frequency will decreases. Second, you talk about from what? From just now 970 hertz to 930 hertz. Like this, you can score 2 marks. Okay, when it's towards, the frequency is maximum. When away, the frequency is actually minimum. Okay, so this one is 330 plus 7.5, 950. So your answer should be 930 hertz. Okay, 2 marks at here, you mentioning frequency decrease, but how it decrease? From what to what? In more detail, so we tell them that from 970 to 930 hertz. Is it okay? Okay, so we goes to your next page. Okay, a source of sound is attached. Actually, it's same like just now the question. Your source is moving in circular. Okay, then you are the observer standing there. The source move with a speed. So this one label, source move with a speed, Vs label. Emits the sound. The source emitting the sound. So this one is frequency due to the source. Speed of the sound in the air. This is V. Observer standing a very long distance from it, calculate the minimum frequency. So ask yourself, minimum frequency is towards you or away you? At the point that towards you or away you? Ask yourself. Observed frequency is minimum is meaning that right now is it should be towards you or away you. Correct, Prasan. Away. So that means that at the point. Now the question is asking you about this point. Here is the minimum frequency. Towards you, this is the maximum frequency. Three significant figure. Calculate what is your frequency. Prasan, correct. Good job. Vashini, 2 significant figure. So I will deduct you 1 mark. Fawal, correct. Fatima, 3 significant figure. I will deduct your mark also. Wesley, correct. Okay, so at here, those give me the answer 920. I will deduct you 1 mark because what you did is actually 2 significant figure. Okay, so V over V, Vs, then Fs. So this one away, we should using plus. Okay. Then at here, 330 divided by 330 plus 12. Then 951. Your answer should be 918 hertz. 1, 2, 3. Can any of you tell me 918 point something or 917 point something? Can you tell me? The real before we round off to three significant figure. Any of you can tell me before we round? Okay, Hassan told me is FO equals to 917.63 hertz. Okay, so boys and girls, we want make it three significant figure is 1, 2, 3. 3, then we look at the number behind it, whether we can add 1 or not. If yes, then we become 918. So for those who give me 920, you are make it two significant figure. That is wrong. Wow, thank you. Washington, thank you. Okay, so you get what I mean, Okay, here. Circular path. Okay, we have a circular path with a radius. Okay. So that means that this one like this. Okay, we have a radius 2.4 meter. Okay. Determine the shortest time interval between the observer hearing the sound between the time interval between the observer hearing the sound of minimum frequency and maximum frequency. Oh, what is the difference in time? Minimum frequency, maximum frequency. So label here, this is towards you is maximum frequency, away you is minimum frequency. From the time we hear the maximum frequency and from the time that we get the minimum frequency, what is the time interval between them? Okay, this one can be solved how? Okay, the distance, let me have a look. How fast they travel? 12 meter per second. Speed equals to distance divided by time. Right, dear? Okay, because it's travel with a constant speed here. Travel with a speed. Okay, it's constant speed. I think here, yes, here got mentioned constant speed. So from here to here, every 1 second they travel 12 meter. Okay, every 1 second they travel 12 meter. So at here, the question is, what is the time? 1 second travel 12 meter. But my question is, from minimum to maximum, how far it travel? How far it travel, the distance it travel for the source to travel. Then how fast it travel is 12 meter per second. So now I want to know how far it travel from the maximum frequency to minimum frequency. Any of you know how far the distance it travel? This is your mathematics. This is not physics, it's mathematics. Fatima have to half of it because this is semicircular. Correct, Joray. So can you, okay, if a circle actually is 2 pi r, right? Circumference is 2 pi r. But right now, from the maximum frequency travel until minimum frequency, we only travel half of it. So it should be half of the 2 pi r. Prasan, correct. 1 over 5 pi, 1 over 5 pi, 1 over 5 pi. Far while, no. Okay, so at here, 12 equals to 1 over 2 divided by 2. So it will be pi times 2.4 divided by t. If you do mathematics correctly, you should get 0.63 second. How long the time, okay, it travel from maximum frequency to minimum frequency. I know that from this point to that point, it travel with a speed of 12 meter per second. Then I want to know the distance it travel. The source travel in semicircular. Wesley correct. Washini correct. Okay, so boys and girls, is that clear for this question? Can I? Actually, this question is not Doppler, but this question is combined with the year 10 knowledge about the speed, distance, and time. Okay, so here, if okay, then we go to your next page, dear. Figure 4.2 show the car on the road. Observer standing at point O. Initially, the car is parked at the point X. Oh, initially is here. Then after that, which is 120 meter away from the point O, the car moved directly towards, keyword towards. So here towards, okay, it's moving towards. Ask yourself, your FO should be higher or lower? And then stop at point Y. The car horn continuously emit the sound when the car moving from point X to Y. So when the car is parked at the X, the frequency that detected is this. Detected by the observer. So boys and girls, detect by the observer. This one is FO. Okay, this one is FO. Then the car move from the X to Y. So it's towards to the observer. Towards to the observer, actually your frequency should be higher or lower. Ask yourself again. Same question, okay? The maximum change in the detected frequency is 16. So you have to think, you should plus 16 or you should minus 16 when it's moved towards. That is the thing that you have to think. First question, ask yourself, towards or away? What happened to your observed frequency? It should be higher or it should be lower. So now I should plus 16 or I should minus the 16 for my observed frequency. Okay? Then after that, the speed of the sound. So this is V. Determine two significant figures. So read the question, two significant figure. What is the minimum wavelength? Oh, wavelength. V equals to F lambda. Wavelength. Related with speed, related with frequency. So this is V equals to F lambda. Minimum frequency, as I told you that your wavelength is shorter, then your frequency should be higher. Right? So minimum, this one minimum, that means your frequency is maximum. So which means that I should using the 800 plus 16. Then this is the minimum. What is the speed of the sound? Speed of the sound is 330. Okay? So you will get wavelength minimum. Actually, what is this? So again, towards. Towards. So your frequency should be higher. From X to Y, so your observed frequency should be increased. So we should adding up 800 plus 16. Okay? Make your answer in two significant figure. Very good, Fawa, very good. How about others? Can you give me your answer? I want to see whether you're giving me two significant figure or not. Fatima, correct. Bashini, correct. I'm worried you will give me 0.4. I worry that you give me 0.4. If you give me 0.4, I will minus your mark is because this is considered as one significant figure. Point in front of point, 0, that is not counting. Only after that we count. So you should put 0.40 is only considered as two significant figure. Prasan, okay, for this question, it's moving from X to Y. You are standing at here. So it's actually is towards. If towards, your observed frequency should be getting higher. So they tell you that at point X at here, my observed frequency at here, point X at here, my observed frequency is 800 Hertz. So when it moved to X to Y at here, observed frequency, I found that the difference is 16 Hertz. It changes 16 Hertz. But this 16 Hertz actually should be plus or minus. So you have to ask yourself, now it's towards what? Towards. So my wavelength becomes shorter, my observed frequency must be higher. So that means that this one, it should be 800 plus 16 Hertz at point Y. You get it what I mean? Okay, so at here, they're asking you minimum wavelength. Minimum wavelength, that means that you are at the highest frequency. So we should add it up together. Okay, so at the end, you get 0.40. If they ask for the maximum, yes, correct. If they ask maximum, then you have to, meaning that it away from you, minus it. Yes, correct. Okay, what is the maximum speed of the car? Car. Car is the source what? So they're asking you Vs. What is your Vs? Fo equals to V over V Vs Fs. Ask yourself, towards from X to Y, towards using plus or using minus? Okay? Towards. Frequency become higher. So actually we should using V minus Vs. Okay, do your calculation and then tell me what is your Vs? Washini, good job. Wesley, why slightly different with me? Eh? Washini same as me, but just now Fawa and Wesley answer are the same. We are 0.1 difference. Why? Okay, here. My answer here, X16 equals to 330. Then 330 minus Vs. This one is 800, am I right? Source. Frequency due to the source is 800. Then what is the difference with me? Why you get 6.6? I get 6.5. I get 6.5. Prasan correct. But why two of your friend getting 6.6? Which part is mistake? I can't find the difference. Is it okay, dear? I don't know. 6.6 is never mind. Should be. Oh, okay. 6.5 is correct. Okay, dear. So this answer is 6.5. Here. What is Doppler effect? Describe the Doppler effect. Is your observed frequency, it will change. It might be increase or decrease. Okay, when, why? It's because the source moving towards or away from you. So this is Doppler effect. Okay, so can you try with this question? If I didn't give you any tips, because this is the last question for your Doppler effect lesson. So can you try? I don't give any hints. Do you able to count it out? Wesley, let me have a look. Answer correct, but it's not the direction. Direction is wrong. Wow, Washini, correct. Good job. Direction is should be towards or away. Wesley, so think again. You see from 400 hertz. After that, the observed frequency becomes 360 hertz. So basically, it should be towards or away. How about others? Is the source. Horn with a frequency. So this one is FS. Okay, observer hear the sound at 360. Ask yourself, is towards or away? Correct, Jory. Far wow direction correct, but the magnitude is wrong. Okay, so the speed of the sound is V. What is the magnitude of V of the car? That means that Vs, car is the source. So at here, FO equals to V over VVS Fs. So this one, FO is less than Fs. That means that your observed frequency decrease. So observed frequency decreases. It means that your wavelength become longer. So it's away. It should be away from the observer. Get it? Fatima, correct. Prasan, correct. Okay, so at here, if this is away, frequency decrease. So this one we should use plus. Okay, so we should using V plus V when it away. Okay, so I do substitution. 360 equals to 340 divided by 340 plus Vs times 400. So your Vs at the end, you should get 38 meter per second. Let me check Fawal. Correct, Fawal, correct. So the behind question actually is your self-practice. Okay, if you're facing any problem, you can WhatsApp message me. I'll print screen the working step for you to have a look if you're facing any problems. Okay. So boys and girls, is that clear for Doppler effect? You need to always ask yourself, what is the source? Is the car? Is what? Okay, what is the source? The frequency due to the source, the speed due to the source, and then ask yourself, now is towards or away? So towards or away, Doppler effect, you have to think about the observed frequency. So it's away or towards. So we come back to here, the notes at here. This is very important notes here, okay? So it's towards or away, ask yourself. So if away, your observed frequency should be lower. If lower, then you should using plus. For the formula, you should using plus. Okay, in mathematics, one value divided by a big value at the bottom part, so you will get a lower frequency, observed frequency. So this part, this one is page number 2. This summary is the main point for this lesson, okay? So actually, we just read the question, we analyze what is your FSV, VS, FO, okay? Then after that, actually we didn't talk about this, but just now we already solved the problem. Okay, when observer is standing at here, okay, this will be your maximum frequency. Okay, this one will be your minimum frequency. It's because here is towards. Here is away. Okay? Is it okay, boys and girls? If okay, then we goes to lesson number, next lesson. Okay, digest, we goes to lesson number 31. Okay, we goes to lesson number 31, Okay. Okay, electromagnetic spectrum. Actually, in year 10, we already learned what, right? In year 10, we already asking you to memorize the 7 EM wave. Am I right? Okay, here I'm going to teach you how to memorize the 7 EM wave. But the problem is, if you are not Malaysian, you might unable to get my point, okay? But if you are Malaysian, then easier, okay? So let me have a look at any of you. Your name is starting from R? No, none of you. The name starting from R. It's okay. Do you know that Ramly Burger, Ramly? Okay, we assume there is a name, a boy name called Ramly. Now today, Ramly actually got ex-girlfriend, Indian ex-girlfriend. Okay, but the ex-girlfriend meanings that already break up lah. Okay, but Ramly trying to get back. Okay, so Ramly make Indian vegetable untuk ex-girlfriend. Ramly make Indian vegetable untuk ex-girlfriend. Okay, so this is the way how I memorize. Then important this is girlfriend what? So when Ramly quarrel with girlfriend, ex-girlfriend must be quarrel before they break up. When quarrel, girlfriend frequency is high or low? Ask yourself. Girlfriend frequency will be high or low when they quarrel. So if you are a girl, you will know that, right? Fawwa, yes. Fawwa got girlfriend, so you know. Okay, the frequency will be high. When quarrel, frequency will high. You know why they quarrel? Because Ramly want a slim girlfriend. He want the girlfriend wavelength is small. Wavelength is something like this. Okay, for example okay. For example, wavelength is from here, wave front. From here to here called wavelength what? But Ramly want the girlfriend wavelength is short one. Okay, slim one, wavelength short. That's why quarrel. Okay, that's why quarrel. When quarrel, girlfriend frequency become high. Okay, so at here, when the girlfriend here gamma frequency high, of course your radio frequency will low. They are opposite. Okay, so when the girlfriend wavelength is short wavelength, then radio will be longer wavelength. Then inside the visible light at here, we got 7 color. Red, orange, 橙黄绿绿绿蓝靛紫 Okay, red, orange, yellow, green, blue, indigo, then violet. Okay, so at here, red R-E-D. So what is this? I is called infrared. Can you see that? It's follow. This one followed by the red color. Okay, violet V at here actually followed by ultraviolet. Okay, so if you have to be very clear, red color wavelength is longer or actually blue color is wavelength longer. So they like to asking this kind of question okay? They assume you have to know. So from this setup, arranging, we know that radio on your left hand side radio wavelength is longer. So of course your red color wavelength for red color, if they asking you any value blue color, it will be longer. So this is the point that you have to memorize and you have to know in our year 10. Supposedly before I teach you, you already know about this, okay? So at here, one more thing you have to know that they all are transverse wave. They can travel in vacuum. They have same properties like the light. They are traveling at the same speed, which is 3 times 10 power of 8 meter per second. So most of the time, they like to asking you to using this formula, V equals to F lambda, but they won't tell you what is your V. You have to automatically understand EM wave. The speed is 3 times 10 power of 8 meter per second. You have to automatically know about this. Okay, the speed in the air is almost the same as the speed in the vacuum. So all these EM waves are transverse. They can be refract, diffract, polarize, and interference. Okay, some of them maybe is new. Some the terms is new for you, but we will learn. Okay, we will learn. Reflect, refract, diffract, interference. If you are SPM student, you know about this already. But if you are IG student, you don't know about interference. Polarized is new topic in our A level. Okay, they have here, like what I told you, Ramly make Indian vegetable untuk ex-girlfriend. Ex-girlfriend wavelength is short. Okay, slim one. Radial wavelength is longer. Quarrel girlfriend frequency is higher frequency. Is that clear, dear? Okay. Only Fawa okay? Fatima okay? Then I proceed. The higher the frequency, the higher the energy. That's why gamma ray is very dangerous. Because gamma ray is the girlfriend, what? G girlfriend. Gamma ray is girlfriend. The girlfriend frequency higher, the energy actually is also high. So we are not encouraged to under the gamma ray. Okay, this one is so dangerous, easily to get highly ionized. Okay, this one we learn in year 10. Ionized is the um radiation hit the electron out from the molecule. So the molecule become ions, become positive and negative. So it might be very harmful to the cell or tissue. So this one goes to near to the girlfriend side. All are very dangerous ones. For example, your X-ray. Actually, half of the year we only can do one X-ray. You cannot every month you want to check body checkup. You every month goes for the X-ray. Cannot Okay, ionize is this, let's say is a molecule. Then the radiation come here. Okay, radiation hit it and then knock the electron up. So it will become positive. Here become a negative. It become ions. So this is called ionizing. Okay, this is called ionizing. Radiation with lower energy is good for communication and then less harmful. For example, we are using radio wave, we are using microwave, right? Okay, so this is safe for us. Okay, the radiation is safe for us. So at here, there is one challenging part in our A level is, okay, this part, you have to memorize the range for the visible light. You have to memorize the range for the visible light too. Okay, visible light from red color to violet color. This diagram here. Okay, from red color to the violet color. What is their range? 400 nanometer to 700 nanometer. Okay, here, this is the roughly range for the wavelength. You also need to know that is the difficult part and challenging part in our A level for this subtopic. You have to know about this. But impossible we memorize, am I right? My suggestion is we need to know about this visible light. We need to know about this visible light. This one, no choice, have to know. Okay, then from here, we're trying to identify is actually longer wavelength or shorter wavelength than the visible light. Using the technique that I told you just now, the girlfriend is slim one. So if you go to the right hand side, actually the wavelength should become shorter. Okay, shorter wavelength. Goes to the left, near to the radio, actually wavelength become longer. So here I trying to find some method for us to memorizing. Okay, so this is what I can find. Okay, here roughly negative 12. In between, but we can plus minus, you see 13 to 16. So negative 12, negative 10, negative 8, negative 6, negative 4, negative 2, and 3. So we roughly memorize the range, From there, we're trying to find what is this radiation based on the wavelength that we know. Okay, negative 12, negative 10, negative 8, negative 6, negative 4, negative 2, 3. Of course, this one can be plus minus. For example, this one is 10 power of negative 7. Plus minus. Okay, later when we do the past year, we're trying to refer back here again. Okay, here you have to know the range for your A level. Okay, so boys and girls, we're trying to check how the past year question asking for this topic. A student is investigating two electromagnetic waves X and Y. The X has wavelength, this wavelength. Okay, then Y has a frequency. But frequency, you have to convert it into wavelength first. You have to find what's going on with your wavelength. Okay, so first, wavelength X actually is in which range? -7. -7. It should be in which range? So ask yourself. I told you, you have to memorize the visible light 400 to 700. So 400 to 700, we can make it like 4 times 10 power of -7 to 4 times 10 power of 7 times 10 power of -7 meter. Nanometer, yeah, meter. Okay, you see wavelength X is in the range of our visible light. Visible light range have to memorize. The rest is we agak-agak, okay? We estimate it. Plus, minus, doesn't matter. So can you see that this 5.2 times 10 power of -7 is actually in between our visible light. So this is the answer. This is the answer. How about another one? Okay, here you see a frequency. This is an electromagnetic wave. Their speed is constant. It's 3 times 10 power of 8. That's why I told you. They won't tell you, but we know. 9.4 giga, tera giga. Giga is times 10 power of 9. Wavelength. If you press your calculator, it should be 3 times 10 power of -2. So -2, we come back to this. -2. -2. -2 is in the range of microwave. So come here. Is it microwave? So boys and girls, did you able to get the idea? From the wavelength to identify the EM wave, okay? So it goes to your page number 3. You always write down visible light. From visible light, we go through to the others range. Okay, which one is not possible? Not possible. So using the technique that I teach you just now, from the last one, Ramli makan Indian vegetable untuk ex-girlfriend. The last one is -12, -10, -8, -6, negative, how many? I is -4, -2, 3, roughly. Okay, here. Gamma. Is it possible gamma is -13? Is it possible gamma times 10 power of -13? My answer is yes. It's possible. Wesley, correct. Okay, then how about X-ray? X-ray is times 10 power of -10. Is it correct? Yes, in the range, possible. Infrared, infrared is here. So infrared is -4, -6. So this one we're not sure yet, but we can try lah. We can try, okay? But then just now I told you what, right? Our visible light, visible light is 4 times 10 power of -7 to 7 times 10 power of -7 meter. Am I right? Okay, this one is 3. That means that it's below the longer. Yeah, longer. Is it possible? It's above the visible light. So that means that the infrared 3 times 10 power of -6 also correct. Because here it should be a longer wavelength. So it's longer than the 4 times 10 power of -7. So it should be correct. Microwave, we check microwave. Microwave is should be -2. But here -5, dear. -5. So this answer is wrong. Is it okay? Fawal say, Fawal, you means the infrared, right? You get what I mean or not? Here, dear. 4, below 4 is infrared. So if below 4 times 10 power, longer than 4 times 10 power of -7, they are correct. Okay, yeah. Line number 3. Okay, can you try? Before I told you. But you have to convert, P, P. What is P? What is micro? Using a calculator to help you. Okay, let me check Prasan answer. Prasan, careless. Wesley, Fawan correct. Fawan, good job. Washini correct. How about others, dear? Okay, I already convert from pica to the actual value, from micro to actual value. So times 10 power of negative 10. It should be X-ray. It should be X-ray. You see, it should be at X-ray area. So it should be X-ray. Then 1 times 10 power of negative 4. Then it should be infrared. So your answer should be C. Let me check Prasan. Correct, Prasan. Jorek, correct. Jorek, correct. Okay? So can you get some idea the roughly range that I let you memorize? Because negative 12, negative 10 is just minus 2, minus 2, minus 2. Of course, here inside got plus minus lah. But we will always remember the 400 nanometer to 700 nanometer for the visible light. Okay? Then we go to your next question. Oh, this one is the same thing. Just repeating it. What is your answer? Correct. Correct. Fatima, wait for me. Correct. All correct. Fatima, your question is number 3. Okay, Fatima here. The rest just now you answer my question 4. You all are correct. You may go to question 5. Okay, Fatima here. Pika. Pika. We got the prefix. You know prefix. Prefix is tera, giga, mega, kilo, deci, centi, milli, micro, nano, pico. It's 10 power of 12, 10 power of 9, 10 power of 6, 10 power of 3, 10 power of negative 1, negative 2, negative 3, negative 6, negative 9, and negative 12. This one you can using your calculator to help you, but if you don't know, later on after that, after the lesson, you capture your calculator and you send to my WhatsApp. I teach you how to find the prefix in your calculator. Okay, then here, 100 picometer. Pico is times 10 power negative 12. This one. Okay, so after that, I get 1 times 10 power negative 10. So which is X-ray? It should be X-ray. Then 100 micro. Micro is meaning that negative 6. Okay, so I get 1 times 10 power of negative 4. It should be infrared. So Fatima, okay, then you mark it down. Number 4 is answer B. Number 4 answer is B. Actually, it's same technique. Number 5, any of you can tell me? Actually, all these questions you can do it. Let me check number 5. Wow, correct. Wesley, correct. Vashini, correct. Good job. That means that you roughly know how to identify. Answer is B. Those who don't know, you write a small answer. If you still cannot, you write the final answer at here B. Then after that, when you are free, you study again. Then you come back and do again. You don't circle first, okay? Number 6, can you guys try? Tell me what is this? They give you frequency. Fatima, this one is prefix also called tera. Tera giga. So this one is actually times 10 power of 12. So you need to find the wavelength. What is the wavelength? From the wavelength at here, find out what is the range. Wesley, no? Wesley, no? Jore, correct. Washini, correct. Fawa, correct. Okay. For this one, it's just apply formula and remember convert the prefix. So the wavelength that I get is 1 times 10 power of negative 5 meter. Okay, so negative 5. Infrared is plus minus at here. So your answer should be A. Infrared. Just now, who was the one answer wrongly? Let me check. Wesley, you choose visible light. Wesley, visible light cannot be wrong. It must be 4 times 10 power of negative 7 to 7 times 10 power of negative 7. Other than this range, no, it's not visible light. So this is not in the range. So it won't be D. Okay, can you guys try question number 7? Wesley, did you get my idea? Okay. Number 7, line boys and girls, speed up. Wow, Joreen, very good. Pawang, no? Washini, correct? Pawang, correct. Okay, boys and girls, at here, your answer should be A. Your answer should be A. Microwave and visible light. You see, microwave and visible light. Okay, microwave and visible light. So you are negative 2, negative 6. This one can be negative 7 what? Okay, 4 times 10 power of negative 7 to 7 times 10 power of negative 7. Although I write negative 6, it's just for us to easier to have the sequence only. So at here, if 10 power of negative 2 divided by 10 power of negative 7, which is 10 power of negative 2 minus 7. So you get 10 power of 5. Answer should be A. Okay, boys and girls, question 8, 9, 10, 11. We write final answer at the bottom. You do it by yourself. Is it okay? Okay, this one settle. Is it okay? Question number 7. Okay. This one at the bottom part at here, I want you write the final answer for you to try by yourself. Your answer should be D, B, C, and C. D, B, C, and C. When you are free, then you go through one by one using the technique that I teach you how to memorize. Okay? Then is it okay? Have you writing down? Then I want to go to page number 6. I also give you the final answer. Yes or no, dear? Okay, here. This one, question number 12. A, infrared, 36 terahertz. Then question 13, answer A, 3.7 times 10 power of 15 hertz. Then B, actually number 2 lah. It should be UV. UV light, ultraviolet. because of the wavelength. The wavelength is 8.1 times 10 power of negative. How I know it's ultraviolet based on the wavelength. So these two, page 5 and 6, can you do it by yourself? I want to go to the next lesson, lesson number 32. Is it okay, dear? Not a difficult question. That's why you can try by yourself. Okay, then we go to lesson number 32. Last subtopic for our chapter 7. Okay, polarization. Just now I said that EM wave is a transverse wave. So it can happen reflection, refraction, diffraction, interference, and one thing I told you is new thing in our A level, which is called polarization. Okay, polarization only can be works with transverse wave. Okay, longitudinal wave cannot. That's why here all types transverse wave can show. Longitudinal wave cannot. Sound cannot show polarization. Okay. Polarization is actually oscillation are in the single direction, which is perpendicular to the directions of the propagation. Okay, because transverse is how it move up, down. Then here, this is direction of the wave, perpendicular. So this one, polarization. Actually for the light, okay, you look at this, I'm polarized. It will be in all direction, okay, in all direction. But when we make it polarized, we will steer it into one direction only. It depends on how we polarize it. Do you see? It will become only one direction, single direction only, or we say single plane. Okay, so let me show you the what. Okay, this one. You see, polarized. So this is transverse wave. Okay, if the way you polarize is same direction, then it can pass through. If here, this one is vertical, but you shake in the horizontal, so it cannot pass through. You will block it. So if in the same direction as your polarizer filter, then it can pass through. Okay, it's roughly the idea is this. Okay, you can think that polarized is something like we got a lot of tiny slits, okay, to block it. We only allow it in a single direction. We only allow the wave travel in the single direction, okay? So if wrong direction, it cannot pass through. Let me have a look another one. Polarization is very important in our life. Actually, we apply it in our life. For example, the spec. Okay, here, this one. See, we block some of the light from others position. Okay, we block some of the light from others position. After that, we will be very clear. Here, there is a lot of direction comes into our eyes. So once we having the polarization filter, we block others direction one. Okay, then this one also. If you go to the museum, want take photo, there's so many reflection. Then we having the polarized. Clamp on your camera. Can you see that all the reflection will be gone? Because those in the wrong direction or not the direction that we want, we will block it. We only allow the vibration in single direction that we want. Okay, so this one,
一个小光点。现在我们把一个片。
Okay, here there is a laser pointer. We put the polarized filter. So we're trying to like rotate. You will find that the brightness will become dimmer and then becomes brighter again. This is what we are going to learn today. Okay, the filter, when you turn in some rotation in some angle of rotation, we will find that it will block the intensity. Okay, in the wrong direction, in the perpendicular direction with your wave, it will block it. Okay, it will block it. You'll find that the red light will become disappear. And here is actually fully blocking the wave. Okay, the wave incidence wave. Okay, here Oh, no more. Okay. So at here, wait, here. Okay. So this is a case without polarize all direction. After polarize, we can determine what direction we want. And at the end, the polarize, it will only in a single direction or single plane. Okay, we goes to the next page. You see, this is the filter, polarizing filter, or we say polarizer. So this one, if you are make it vertically and you shake vertically, up, down, so it can pass through. But if you make the filter vertically, but you shake left, right, so it cannot pass through, it block it. Okay, so we can think that polarizer is something like many tiny slits. Just now the video, okay, showing you there is many tiny slits, something like that. Okay, to demonstrate to you. Okay, so at here, this is what I told you, the sunglasses. Okay, we can block some of the light that wrong in the wrong direction, we can block it only. Okay, so next. Okay, boys and girls, we go to page number 3. Malus law. Okay, this one. When is exactly just now the video, did you still remember the laser light, red color? So I trying to rotate my filter. The brightness of the laser pointer actually will decrease until a certain moment it become totally no more the laser pointer brightness is gone. Okay, it's become totally black. So that one is when it is perpendicular to your wave. But before we perpendicular to your wave, we're trying to rotate it. Actually, we only block some of the intensity. Okay, not blocking off until it's exactly is perpendicular to the uh polarization of light direction, that it will become zero lah. But once we start to rotate, the brightness, just now the video showing you, the brightness will decreases. So we want to know how to calculate the intensity that it decrease. So we were using this law, okay, Malus law, to do calculation. So this formula you have to know. This formula we have to know. Okay, here. This is the initial, IO is initial light intensity. Or sometimes we label II, incidence. Okay, doesn't matter. This is the transmission. Okay, after transmitted light intensity, we label I or IT. Okay, so it depends on your angle that you rotate. It depends on the angle that you rotate. So we're using cos square delta. So if let's say it is same direction as your wave direction, if this is same direction, it's something like this. If this is same direction as what you move, okay, so that means that 0 degree you are not rotate. After you rotate 180 degree, you also showing this pattern. So 0 to 100, 0 and 180 degree at this position, your cos square data you will get 1. That means that at this position, you are allowed all the light passing through. This one is 1. So your light intensity equals to your initial light intensity. So in 0 and 100 degree, your filter rotate in this angle. This is the maximum light that we can get. Maximum light. Recall to the video just now. Okay, before we rotate, it's actually 0 degree. So we start to rotate until 90 degree. All the laser light is blocked. That is 90 degree. Because when 90 degree, your cos square data is become 0. This one is 0. So 0 times IO, of course 0, it block all the light. So at the moment, that is the minimum intensity transmitted light. That's why my laser pointer from bright to dim become totally no more laser light showing on the screen. Okay, until here, is that clear, dear? The angle will affecting the video. Just now, this video. Is it okay, dear? This one. Yes, you see? Filter paper initially at 0 degree, it can pass through. Nothing changed. But start to rotate, it become dimmer, dimmer, dimmer until 90 degree is totally blocked. Then we continue rotate, rotate, rotate 180 degree. It will go back to the maximum. Okay, maximum light. Okay, so boys and girls, we go to your next page. Okay, light intensity, we can also using two polarizer. Okay, so this one at start, you see, at start, we got many direction. And polarized, they are in all direction. After passing through the vertical filter, it will only allow these directions of the light can be passed through. Then this one be also in vertical, so it still allow it to pass through. Okay, it parallel, it allow it to pass through. But if these two polarizer is perpendicular to each others, what will happen? Okay, the light adhere in all direction. Okay, and polarized. After that, this one is polarizer with vertical slit. So it will allow vertical light passing through. But this vertical light comes to here. Your second polarizer, which is the filter, you rotate 90 degree to compare to the first one. So at here right now, your polarizer slit actually is like this, but in moving like this, how can you pass through? At the end, no light can be transmitted. At the end, no light can be transmitted. Okay, so this is the one just now we saw the laser pointer. Okay, the second polarizer. Okay, the first one we didn't do anything lah. We just let it polarize. So make it having a vertical polarized light. Okay, so starting is the same. The second one is the B filter. We rotate the B filter. Okay, we rotate the second polarizer. So at start, I haven't rotate. At start, I haven't rotate. At this position, I allow all the light passing through. So this one is maximum light intensity. Then I start to rotate. Until 90 degree, I block all. So can you see that? Maximum until 90 degree, I block all. Then I continue to rotate. I start again to getting the value. So I get this pattern. I'll rotate the second polarizer. I start at here. This is 0 degree. Then all the light can pass through. So this one light intensity is maximum. Then after that, I rotate the second one 90 degree. Okay, because I rotate 90 degree, just now using this formula, cos square theta is 90 degree, 0. I block all. No light will be transmitted, no light. So this one is minimum. Okay, the light becomes 0. Can you see that? I'm plotting at here 0. This is maximum. I continue rotate until 180 degree. Actually, I get back to this position. Rotate 180 degree. I rotate back to get this position. So I get back another maximum. Until here, is there any question? Do you able to get the idea? It's new thing for you. Okay, polarization is new thing for you. Okay, okay. Okay, then if okay, I want to come back to here talking about teacher, why longitudinal wave cannot? Why longitudinal wave cannot? You imagine longitudinal wave is we move forward and backward, forward and backward, forward and backward. Am I right? Longitudinal is forward, backward, then the wave travel in this direction. No matter what kinds of filter that you use, it's just passing through only. It's just passing through, nothing to block. If you're using the horizontal one, it's still passing through only what? Left, right, left, what we say? Forward, backward, forward, backward. So at here we say, longitudinal cannot show polarization because nothing to block it. How it travel? It travel forward, backward, forward, backward. No matter what kinds of filter at here, they're just passing through only. Do you get my idea there? Why longitudinal wave cannot show polarization? It's because longitudinal wave is forward, backward, forward, backward. No matter what kinds of filter you put at the front, they're just passing through only. Nothing to block it. Okay? So if okay, we're trying to apply formula. We're trying to apply formula. We go to your page number 5. Okay, let me have a look. Page number 5. Okay, we go to page number 5. I teach you how to using formula. Okay, here initial IO. After passing through IO, I can label here as I1. After passing through the filter, then this one is I2. After passing through the second, I2. Okay, what we say, what is the intensity of the light beam after transmission to the second filter? So they're asking you what is your I2 lah, right? Okay, I1 first, we go to I1. Then I1 is IO cos square angle. This is the Malus law, this one. I equals to original light intensity cos square theta. The delta at here, angle, is from here to the axis. Okay, to the axis. So we look at this. Okay, from here to the axis, 45 degrees. So we put 45. Okay, cos square 45, actually we get half. If you press your calculator, you get half of it. Okay, that means that I1 is half of your IO. Is that clear? Is that clear, dear? Okay, then we want to analyze how about the I2. I2 is your I1 cos square. What is the angle compared to your first filter? How much it continue to rotate? How much the angle difference between the first and the second one? First filter and the second filter. So you look at me, just now 45 is somewhere here. Now your second one is actually another 45 degree compared to your first one. Because right now we are based on your first one, what? Based on the first one, I continue rotate my second filter, another 45 degree. You get what I mean? The second one, the angle should be based on comparison with the first filter. Is that clear, dear? So this one is half IO. Then cos 45 is another half. So your answer should be 1 over 4 IO. Answer should be B. The main thing that I want to teach you is it should be based on your first filter, compare how much right now we continue rotating. The angle at here, angle between the polarized light and the transmissor's axis, okay, transmission axis. Okay, then until here, is it okay? This first question is warm up for you to understand what angle we use, okay? Then second one, a bit difficult, but should be okay lah, okay? Here, a source of plane paralyzed light. Okay, this is already polarized light through the two filter. Initially, this is the filter direction. This is the filter. That means vertically lah. Initially, the filter is vertically like this. The filter are positioned so that the source appears at its brightest. So initially put like this, we will get the brightest. That means that starting at here, your polarized light actually is also vertically like this. It can pass through. Initially, it can just pass through. Okay, then they tell you that one of the filter rotate clockwise. One of the filter clockwise, another filter is anti-clockwise, but they will having the same angle. They will rotate with the same angle. They're asking you, how does the source will appears when both filter are rotate 90 degree? Okay, here, if your filter at here, starting like this, if it filter and become 90 degrees, so your filter become like this. Rotate, become like this. Then another one also like this. Can you tell me, you will getting 90 degree, your paper? You can using your paper as your, you cannot. You're using your paper and then you rotate, okay dear, you rotate. Then after that, can you tell me, when the first one rotate 90 degrees, the second one rotate opposite direction 90 degree, you should get a brightest or actually is darkest source. What do you think? Prasan correct. How about others? Wesley correct. You imagine it rotate 90 degrees. Like just now what I told you here. If you rotate 90 degrees, you will get the light intensity actually is the minimum. You rotate 90 degrees. See, rotate 90 degrees. Starting is going like this. But you make your polarizer is become like this. Rotate 90 degrees. So at the end, you will block all. Dear, you will block all. Okay, here, let me have a look. Prasan, they trying to trick you? So far, okay lah. Fawal, correct. Fatima, no. Almost there. Washini, correct. Okay, so boys and girls, it rotate 90 degree. This one rotate another 90 degree. Since they rotate 90 degree, they already block. No need to go to second one. Actually, the first one already blocked off. If they can pass through the first one, okay, let's say first one didn't move lah, didn't rotate. It goes to second one is also blocking because 90 degree. So at here, it must be darkest. Because 90 degree will block, dear. It will block. Okay. Then how about 180 degree? So you imagine this one. If you turn 180 degree, actually you get back to this position. Do you agree? You rotate 180 degree, you get back to this pattern. Do you agree? This one you rotate clockwise 180 degree, you will get back to this position. So if 180 degree, we come back to here. 180 degree, you get back to this position, you will get a maximum light intensity. So for this question, our answer it should be C. Get it? Okay, 90 degree will block all. Perpendicular to your polarized light, it will totally block it. 180 degree, actually you go back to original pattern. So it can pass through. Okay. So can I proceed to the page number 6? Okay. So here we're trying to practice. Okay, a beam has a polarized light wave incidence on a polarizing filter. The filter can be rotated, so it always in a plane or perpendicular to the beam. The transmission axis of the initially is like this. Initially is at vertically. Initially is vertically, so after that it rotate. The filter is first rotate 30 degree. Then after that we get intensity of this. So first they rotate 30 degree. Then after that they further angle another 30 degree. That means that second case, they are rotating in total 60 degree. You get what I mean? They make it two case. They make it two times. First time is they rotate 30 degree. They get the intensity I30. Then after that, they further another 30 degree. So here, the second case, they already rotate 60 degree. So we can divide it into two cases, okay? Initially, this is original formula. Original formula. When at 30 degree, your intensity should be the original, then cos square 30. Okay, we rotate 30 degree. Then if second case is we rotate another 30 degree. So actually in total we already rotate 60 degree for the second situation. So at here it should be IO cos square 60 degree. Now the question asking you what is your new intensity for the second case? Intensity for the 60. Normally they want you in terms of What? Actually, we're using ratio to solve it. I can using I60 divided by I30. So can you try? Let me check. Wesley, no. If it's your IO, this is your I 30 degree. Second case, they rotate another 30 degree. So actually they already become 60 degree. Vashini correct. Fawal correct. Prasan correct. Here from starting to ending only one filter. From starting to ending only one filter. First case is 30 degree. Second case, I continue another 30 degree. But I continue another 30 degree compared to initially I already rotating 60 degree. So this is my new intensity. So the answer should be B. Yes. I60 should be 0.33. I30. Answer should be B. Is it okay? Can we proceed to question number 2? This question they want to trick you lah. Second case is further 30 degree, but angle we should using 60. 30 then another 30. So actually for second case is 60. Okay, this question is okay. Vertical. Oh, initially it's vertical lady. Vertical polarized beam light. Oh, here vertical. Okay, it's on the transmission of the filter is an angle 40 degree to your horizontal, 40 degree to your horizontal. But this is not the angle we want. We want the angle as it will be initially as the vertical. So the angle that we use actually is here 50 degree. This is the part you have to know. From vertical to the how much you rotate. Now they give you the 40 degrees to the horizontal, but we want from the vertical. Okay, we rotate it. So the angle at here should be using 50, not 40. Amplitude. Okay. We learn about intensity and amplitude. Intensity is directly proportional to amplitude square. So if make it in what? In formula, we can put a constant value. I equals to Ka square. Okay, what they want? Let me have a look. Incidence beam. Oh, okay. Transmission. Okay, I put a T lah. Okay. Then incident, I put I lah. Okay. Cos square delta. Then here the intensity should be Ka square. Okay. So this one should be Ka transmission square equals to Ka intensity square. Cos square data. Actually, I just substitute this into I into I into I. So I get this and this. Okay. Then after that, the question asking us what? A transmission. A incidence. So K and K we can cancel. Cos square delta. What is the delta? So just now I got mentioned the delta actually is your 50. This one should be your 50. Digest. So what is your AT over AI? Okay, digest this question. Fawal, no. Fawal, check again. Which part? Did you square the cos square 50? Correct. Fawal, right now correct. Here there is few things you have to pay attention. The angle is not 40. It's from the vertical to the angle. So it's 50. Then here another question is they want you relate intensity and amplitude. These two relate it. So we know that I can't remember which lesson, but chapter 7 wave, I think it's first or second lesson. We're talking about the intensity. You refer back. Intensity is proportional to the A square, amplitude square. So we just make these combine in, then move here and there only. So your answer should be C. Two things you have to know for this. This is the number one, 50. Number two is this. I equals to Ka squared. Is it okay? Bawang okay? How about others? Can you re-explain very fast? Okay, dear. Okay, one more time, Fatima here. Okay, a vertical polarized, that means that this one starting is vertically. So we assume our filter is vertically lah. How much we rotate? How much angle, the angle that we rotate? Okay, initially is this because this one is vertically, then we rotate it. Here the diagram they give you 40 degree is from the horizontal. This is not the angle. The angle should be from the vertical to the axis, transmission axis, which is the 50 degree. Is actually the angle that we rotate. So if you look back to here, how we determine the angle? From the vertical until the axis. This is the angle 50. So just now what they give us to us is actually give this 40. They give 40. So they want to trick you. But actually we have to know the angle is actually 50, not 40. Okay, for this first part, is it okay, Fatima? This first part? Okay, angle is 50. Okay, then the question asking you amplitude. So for this one, we want to relate intensity because this one polarization, we're talking about intensity, light intensity. So we have to use formula to relate intensity and amplitude. If not mistaken, let me have a look. The intensity is, I can't remember. Yeah, I think this. Amplitude. Where is it? Intensity. You have to find out. Yeah, here. Intensity is directly proportional to amplitude square. So we relate these two. We relate what we learned, okay, previously. So I want to make directly proportional to an equation. So I need to put equal and then I add a constant. So I come back to here. I is directly proportional to a square. I is equals to constants value a square. Then I understand that this is your initial. Okay, I label here. This is your incidence. So I incidence. Okay, this is your transmission. I transmission. I put a T. So the transmission intensity will be equals to the incidence intensity cos square delta. This is Malu's law. They say I equals to IO cos square delta. Okay? Until here, okay, for this part, Fatima? Okay, then after that, I need to get amplitude. So I have to apply this inside the intensity. So I put the KAT square because this is transmission. KAI square because this is incidence. K and K can cancel out because if I move to another side, actually, it should be cancelled out lah. Divided, K divided by K actually is 1 lah. Okay, so K actually the rest is actually moved here and there only. Okay, KAT square divided, I move AI square. Cos delta, delta at here, theta at here actually is 50 degree. This is the part they're trying to trick you. 50. So this one is, you remember to square root it, square root it. This one, it should be, let me have a look. It should be, yeah, I didn't count the value. So at the end, you should square root of cos square 50, you will get 0.64. So until here is two part. One part is this angle is 50. Second part is you link the intensity with the amplitude. So Fatima, okay? Okay. Like dear, I know time's up already, but I want you here at the bottom part at here. Can you here write down the final answer 0.75? And then the second one, answer is 0.19. Okay. Then next page at here. This one settle, you write down first. I want you try it. I want you try it. I want to try it. I want you to try it. Actually, you can do it one. Okay, you can try and do it one. Okay. Then next one, actually, I want you to write final answer 5.7 Wm negative 2. Then it's 52 degree. The angle you get is 17.2. This is not final answer. Alpha is 52. I want you to try these two questions. I want you to try do these two questions. Then next week, I print screen for you. I print screen the working step for you. But before that, I want you to try first. Okay? Then here, what the hints that I want to give you is, you want to do for the second one, I2. You want to I2 relate with I1 cos square delta. So this square delta, the angle, actually you have to compare with the first one, first filter. So you cannot set that 90 degree as your angle. Here initially is 30 degree. You continue rotate how many angle? This angle actually is the angle that you need to find, 60 degree. So this one should be 60 degree when you finding the I2. Compared to your first one, how many angle that you continue rotating it? I want you guys try these two questions, not that difficult, but you try it until you get the answer. Then after that, I will print screen the working step for these two questions for you. The rest of the question we can continue by next week. So is it okay, everybody? Yes, So if there is no question, let me have a look for a while. Okay, so if there is no question, that's all for our lesson today.